right. Hey, everybody. We're going to be doing some more Advent of Code today. So last time we did the first problem from 2022, and we did some 2021 problems, and then I was taking a break for a couple days, so we now have 3 more days, I think, that we could potentially do. I'm sure we won't get through all of that, but, we'll try. But actually, before I even do that, I just wanted to throw this cool thing out there. I saw this on Twitter. I subscribe to a lot of math Twitter, things, and people throw up cool problems, and this was one of them. And it's not very hard. I'm surprised it's any kind of Olympiad mathematics. It's really pretty straightforward. But the thing I liked about it is that it's a quintic equation, so it's an equation in x to the fifth, right? Because we're going to have x cubed times x squared is x to the fifth, and then all the other powers are going to be lower than that. And in general, quintic equations aren't solvable kind of analytically or algebraically. There's a really beautiful story about that basically follows the arc of abstract algebra about Galois, who was like a 20-year-old mathematician or something who died in a duel. But before he died in a duel, he wrote down basically the foundations of abstract algebra, all the way up to proving that you can't solve the quintic in general. But some quintics you can solve, and this one isn't even really a quintic, since you'll notice there's no term in this that doesn't have an x associated with it. Right, it looks like there is. It looks like minus 28 doesn't, but minus 28 is getting multiplied by x cubed. And so, really, this is sort of organized in a way that hides the fact that this is mostly not it's a quintic, but it's kind of easier to solve than that. And the thing I liked, and you can look at lots of people posted solutions, but my thing is that you can do it without pen or paper or a calculator if you look at it carefully. So this is something I would expect, a high school student to be able to solve without using the quadratic formula. Maybe even a middle school student could potentially solve this. And the basic idea, I was able to do it just while staring at the equation in my head and get all 5 roots. You have to make sure that you get all 5 roots. It's really easy to forget that there is a 5th root here as you go through these steps, but you have to get all 5 of them. And the basic idea is just that you can factor this mentally. So I just wanted to do it quickly first because I thought it was cool. Let some people filter in, and then we'll go ahead and do the Advent of Code problems. But let's just look at this first. Why am I not? There we go. Okay, so what's the problem here? It's x cubed times x squared minus 28 is negative 171. X. Yes? Yes. Okay. And so the first thing that you should notice is that you can actually divide out a copy of x from this whole thing, right? There's an x cubed on this side, there's an x on this side. And that's why I say that it's essentially not a quintic, even though it very much is. But we can just say one of the... we can factor out x, which means that x minus 0 is a factor, or x equals 0 is a root. So that's one of our roots. We've already found one of them, and we're down to x squared times x squared minus 28 is minus 171x. And there might be even a cleverer way to do it than this. But at this point, I just multiplied this all out and put everything on one side of the equation. So, whoops, I have an extra x in here. we have to divide x out from both sides. So I took 1x from the term up front, and I took an x from the right-hand side. So x squared plus 171, right? And so now now you're like, okay, great. Now we have a 4-degree polynomial, a quartic polynomial, I guess. How has this helped us? Sure, Galois says maybe we can solve these analytically, but I sure as hell don't know how to solve it analytically. But the thing to notice here is there are only terms of even powers here. Like in particular, if we said that y was x squared, then this would just be y squared minus 28y plus 171 equals 0. I forgot an equals 0 over here. Right? And we know how to solve this. This is just a quadratic equation. Like, there weren't any cubed terms or x to the first power, or like just x terms in here. And so we know how to solve this. And we can plug this into the quadratic formula, solve for y, and then square everything and make sure you count both the positive and negative roots, and you would get an answer. But I probably can't do that algebra in my head. It's going to be 28 plus or minus the square root of 28 squared, I don't know what that is, minus 4 times 171, I don't know what that is, divided by 2. Seems complicated. The easier thing, though, is to recognize that this number factors. On the face of it, it might look like a prime, but it's not a prime. And there's an easy trick that you can use to see that, which is that multiples of 3 and multiples of 9 both have this cool property that the sum of the digits is divisible by 9 or divisible by 3 if and only if the number itself is divisible by 9 or divisible by 3. And so since the sum of the digits here is 171, that's 9. Sorry, 1 plus 7 plus 1 is 9. 9 is certainly divisible by 9, so we know this is divisible by 9. And we can see that it's really close to a number we know is divisible by 9, 180, which is 20 times 9. This is just 1 9 less than that, so this is 19 times 9. And so if you see that this is 19 times 9, you might notice that 28 is 19 plus 9. And if you notice that, and you remember some high school algebra, you will remember this pattern where we have to get the signs right, but we're going to end up with, if we factor it this way, we're going to end up with a y squared, which is correct. We're going to end up with 171, because 9 times 19 is 171. And we're going to end up with a minus 28 here, because minus 9y plus minus 19y is minus 28. So there's this nice pattern that you can always look for in quadratics, where if you have a product of two numbers here and the sum of two numbers here, then you can always just factor it, assuming that a is 0, that the coefficient from y squared is 0. And so now we factored it. Now let's not forget this is x squared minus 9 times y times x squared minus 19. And I do this. I didn't really do this substitution of variables when I did it in my head. I just factored this in terms of x squared because I saw that I could do this. But it's important that you don't forget that, because it's easy to just go, oh great, y can be 3, y can be 9, y can be 19, and x is 0, and so the roots are 9, 19, and 0. And there are a lot of problems with that. One of them is that we need 5 roots. Another one is that I just said x is equal to a thing and y is equal to 2 things, and then I said that all the roots are those x's and y's, and that doesn't make any sense. So we don't want to do that. It's easy to make that mistake, though. I am personally guilty of making lots of mistakes that look like that. So anytime I'm doing something like this where I have a substitution of variables, I want to get out of substituting those variables as soon as possible and back into the thing I was working with in the first place, just to avoid silly mistakes. And so from here, we maybe remember that we can factor x squared minus 9 like this. Or you can just remember that this means that x squared minus 9 equals 0, or x squared minus 19 equals 0, which means x squared equals 9 or 19, which means that x is minus 3, minus square root of 19, square root of 19, because we have to remember that we can't just take the positive root, we have to get both roots. And now we're like, great, we've got our 4 roots, except, whoops, this was a quintic polynomial, we need 5 roots, but we already said what the 5th root is going to be, so therefore solution to the quintic are this, oops, or 0 solves the quintic. And I just thought this was a lovely little problem. It's high school algebra, but it was fun. I like these sorts of problems where, sure, you can brute force them, but if you take a step back and make some observations, you don't have to. You can arrive at the right answer mostly by insight. And in this case, like, literally didn't even need a pen or a paper. And I'm not particularly good at doing mental arithmetic, so I think this is well within almost anybody's grasp. So anyway, I like that. I thought it was cool. I wanted to share it. Let us now jump in to Advent of Code, Day 2. Advent of Code, Day 2. Need to find my tab. I hit it. Find Twitter. Okay. So, Day 2, rock, paper, scissors. The elves begin to set up camp on the beach. To decide whose tent gets to be closest to the snack storage, a giant rock, paper, scissors tournament is already in progress. Rock, paper, scissors is a game between 2 players. Each game it contains many rounds. Does anybody not know rock, paper, scissors? I think everybody pretty much knows rock, paper, scissors, but use a hand shape, and rock defeats scissors, scissors defeats paper, paper beats rock. If both players choose the same shape, the round ends in a draw. Yeah, this is how rock, paper, scissors works. Game theory equilibrium of this, by the way, is to randomly choose which one you're choosing, or you can be like a friend of mine and always play scissors. Or rock, I can't remember, he always plays something. Cool. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide, your puzzle input, that they will be sure to help you win. That they say will be sure to help you win. Quote, the first column is what your opponent is going to play. A for rock, B for paper, C for scissors. The second column, suddenly the elf is called away to help with someone's tent. The second column, you reason, must be what you should play in response. X for rock, Y for paper, Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected, 1 for rock, 2 for paper, 3 for scissors, plus the score of the outcome of the round, 0 if you lost, 3 if the round was a draw, and 6 if you won. Okay, this is a terrible way to score rock, paper, scissors, although there's a really interesting game theory question of what the game theory equilibrium is in this game. I say really interesting game theory question. It would probably be somewhat of a pain in the ass to solve, but nonetheless. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose you were given the following strategy guide. This means that your opponent will choose rock, which is A. You should choose paper, which is Y. You win, and the stupid scoring is done. Same thing. Okay. In this example, if you were to follow it, you would get a score of 15. A plus 1 plus 6. Cool. What would your total score be if everything goes exactly according to your strategy guide? All right. Let's do it. So let's grab this. Let's throw it into input O2, txt, boom. Okay, so these are space delimited all right, I do kind of wish that they would make the inputs a little bit more consistent, just because I find it completely uninteresting having to parse the input every time. But what are you going to do? We have some helper functions for that. Okay, so as usual, let's start with, and if you weren't here last time or you don't know, I pre-generated using handlebars in Rust. I pre-generated all of the these files. Just they're basically placeholders with the boilerplate I need, but it's just nice to not have to create the file every time. You can see I have a YouTube video. I did it on stream, but I have a YouTube video that shows how I did it. Link is in somewhere. Maybe I should create a command for that link. Anyway, if you want it, you can ask. It'll definitely be in the YouTube descriptions when this goes up on YouTube. Cool. So we first need to parse the input here, which is going to be pretty straightforward. We're just going to use parse as string, which is already what we have. And then I think we want to parse these into tuples as well. So we'll say .map x, let's see here, x dot split on a space, and then we'll map this into x dot 0, x dot 1, and collect that. Yeah. New parses string. Oh, we need to into there. Okay. And this is a vector, so we need these, not tuple indexes. It's a split of a string. We can collect this into a vector of whatevers. An iterator. Surely I can call .collect on it. Oh. Missed some parentheses. Okay. Cool. So that should get us the string. What's this? Type needs to be known. Cool. And what's wrong with this? Oh, we don't want these to be at strings, so let's .toString here as well. Okay. And okay, and it thinks it's a vector of string because that's what this these functions take by default. But we're gonna do better than that. We will say that the input is a string. Likewise, we'll do that here as well. A tuple of two strings. Okay. And what happened here? I got one extra paren. Okay. Cool. And let's go ahead and use this. Oops. Input parser. Oh, why don't we like this? Can't return value referencing the function parameter x. X is borrowed here. Uh-huh. Okay. Fine to clone it. This file is small. Still doesn't like that. Cloning the vector doesn't do the trick. So we can clone here, I guess. Can return a value referencing a temporary value. Sure. Yep. I was trying to be snazzy here. Maybe that was a mistake. I mean, really, I know, really maybe the cleaner way to do this is to just say, x.chars, dot take, I guess dot take one, nope, that doesn't work well either. String. Also, I should probably be doing this within the function. Maybe. I want to do this functionally. I don't want to open a block of code. Okay, it likes that better. I wonder why. I didn't totally see where it was storing the value. I guess there was a split of X. And somehow it was getting ownership taken of it, whereas this doesn't. Yeah, I'm not totally sure I understand why this works and that didn't, but let's roll with it nonetheless. And okay. Cool. Cool, cool, cool. Okay, so now everything's compiling, and we expect to hit cargo test problem 02. Does this work? It does. Oh, nice. I should use that more. Okay, and they both fail because neither of them are implemented. That's fine. Okay, so we need to, we have our parsed input. We want to compute the score individually and then sum the score up. So we probably want to have a way to compute the score from one line of input, and that's really all we need. So let's just, I don't really need a test for this, but for the sake of being thorough and minimizing debugging time, let's test can compute score, round score. So we'll say assert equals And maybe the other thing I'm going to do is create a little enum here. Enum, rock, paper, scissors. What are they called? Gestures? What are they called in general? Rock, paper, scissors. A hand shape. Enum hand shape. Rock, paper, or scissors. We can derive all of the good stuff except for default. And ample hand shape. Pub function from string. So if it's an A or an X, that needs to be an ampersand string, then it's self rock. If it's a B or a Y, then it's self rock paper. And if it's a C or a Z, then it is a scissors. And we don't like this, why not? Expected static string, I can't do that. Ugh. I thought there was a nice, I thought I could do this somehow. Does this work? Almost. Yeah, sure. And then otherwise, let's just panic. Let's just panic. Invalid and shape. S. Okay. And that's going to return, so that's good. And then pub function evaluate, and we'll say, let's just do it this way, left hand side, hand shape, right hand side, hand shape, and let's say outcome, and we'll say pub enum, or this doesn't need to be public, enum outcome, wins, win, let's just say win, draw, lose, and outcome, function, score, at self, U32 should be fine, and we say match self, self win is 6 points, self draw is 3 points, and self lose is 0 points. Okay. I mean, this is a lot of extra structure that we don't really need. We could just have this within our code, but it makes it easier to test. It makes it easier to understand, easier to come back to. It probably makes it scale more nicely for the second problem. So now we just say match LHS RHS, and this is self. Let's see here. Is there an efficient way to do this? Not really. Not really. Okay. Rock. Let's just do all of the combinations first. Self rock, self paper, self rock, self scissors. Maybe the easier thing to do actually is to say, what did I just do there? Just for conciseness, if LHS equals RHS, return become draw. And then we can get rid of this case, and we have self paper, self rock, self paper, self scissors. We're expecting 6 items in this. Self scissors, self rock, and self scissors, self paper. This is where Copilot comes in really handy, but I find it feels a little like cheating when you're doing advent of code, so I'm not using it. Panic, it's a draw, but that shouldn't be possible because we already checked for whether it was a draw. So this becomes outcome. So the question is if the left-hand side won, so this is a loss. This is a 1. A win. I know English, it's fine. Hey, Lost Soul. This is Rust, which is my favorite language. It's a systems language, but it's like at the same level of abstraction as C++, basically. So it's super fast, but it doesn't come with a lot of the kind of dangerous foot guns that C++ comes with. And this pattern matching stuff in particular is really, really nice. But in general, I love it. How's it going today? Paper beats rock. Paper loses to scissors. Scissors loses to rock. And scissors beats paper. Okay. Cool. So now we should be able to get our round score just by, I guess we'll do one more thing. We'll say to score self U32 match self, and was it 3, 6, and let's see here, 1 for rock, 2 for paper, 3 for scissors. So self rock is 1, self rock paper scissors is 2, and scissors is 3. Really makes me want to work out the game theory equilibrium for this game. This is like a super silly scoring system, but an interesting game theory problem. Okay, cool. And so now we just want to make sure that I guess we can also hand shape returns an outcome. We can say pub function score round. LHS handshape, RHS handshape, colon, and U32. And for that, we're just going to say self evaluate LHS RHS to score. Or just score. And what's wrong here? Can't find evaluate. Evaluate. Oh. Had the wrong self. Lost Soul says Rust. Interesting. Yeah, it's super cool language. Do you code? What language do you program in? Okay. So now we can say what to say? Hand shape. Score around. Hand shape rock versus hand shape rock. So this is according to the rules of the thing. So this is a draw. So we get 1 for playing a rock plus 3 for getting a draw. So we expect this to be 4. Is that how the rules in Advent of Code work? Cryptid, blah, blah, blah. Where's the score? Score for a single round, 1 for rock, 2 for paper, 3 for scissors, plus the score of the outcome, 0, 3, or 6. Yeah, so that is what I would expect. And these have to be references. Use JS. Cool. Yeah, so if you've ever used TypeScript, that's going to be a little closer to Rust, because Rust is very strongly typed, like aggressively strongly typed, I would say. But it has a whole lot of really nice sort of quality of life features to it. So you can see, for instance, I have to say, well, it kind of doesn't look like it's typed, because I get to do things like say, let shortened input equal this big long thing, and you can see my IDE is saying, oh, this is a vector of string, but I didn't have to tell it that. I don't know how to get my IDE to not say that. Or like here, it's saying answer is a usize, but I didn't have to tell it that. It's able to infer a lot about the type system, but it is very strongly typed. So like all of my functions have to say, this is a reference to a hand shape, this is a reference to a hand shape, it's going to output an outcome, and so on and so forth. So that's going to be one big difference. But it's got really good quality of life features, and the type system, I always feel like actually like helps me write better code and write fewer bugs, which is always nice. Looks like Kotlin. Yeah, I haven't used Kotlin much. Kotlin's like Java land stuff, right? I'm familiar with it, but I haven't really, or I guess I'm not very familiar with it. I'm aware of it, I'd say. Okay, let's go around. Let's do a couple other ones. So let's say scissors versus scissors beats paper. And so you get 3 points for playing scissors and 6 points for winning. So we expect this to be 9. And let's just and then what to do? Let's do paper. And what does paper beat? Paper beats rock. And so we expect that to be, scissors beat paper. So let's do a loss condition. So let's do paper versus scissors. And so then you lose and you get 2 points for playing scissors. For playing paper, rather. Rock, paper, scissors. Yes, you get 2 points. Okay. And let's run our tests and see if that passed. Nope, sure didn't. Okay, what happened? So this guy was 3, not 4. So I expect to get 1 point for this, and this. Aha. Okay, yeah, score round. So I need to not only get the score, but I also need to do LHS dot to score. And there we go. Okay, that one passed. Our other two are failing. That's fine. We haven't implemented them yet. Have not implemented them yet. Okay. Lost Soul, are you familiar with Advent of Code? Have you ever done it before? Okay, so now this should be pretty easy because now we just need to go through all of our puzzle inputs and just score them and sum everything up, which we can just do in a functional style. Why is this a public function? Like this. So we pull it into an iterator and we map LHS RHS into handshape score round. These are gonna have to be they're already references. Great. Those are references, and then so we map that, we score it, and then we sum it. And we're asking for a usize into iter. Can't type today. And then this returns not a usize because these are all U32s. So let's just return a U32. It doesn't really matter. Whoops. Okay. Handshape score round. What's the issue? Arguments of the function are incorrect. Oh, it would help if I actually parsed the thing. Handshape from string. LHS. And same story here. Handshape from string RHS. Okay, and that returns a thing. And let's see how we did. It's still going to say I'm wrong because I'm not actually asserting that the answer is correct. Okay, it says 27. 27 is the total score. That seems very low. That seems very low. I'm skeptical. Oh, but this is the shortened input. Right. I forgot that I did this. I have nice, convenient shortened inputs that I can use for my tests. So the idea is, okay, if we look at the first 10 and work it out, we should be able to test that this is right. I don't really feel like working out the first 10. I think working out the first 5 should probably be sufficient. So let's do that. I'm going to change it down here too to avoid a silly bug later. And what is this? Okay, 18 is the number to beat. Well, the number to get, really. Okay, so this is... I'm just going to copy this out. And do it in the comments here. What happened to my... This is something I haven't quite gotten used to yet about Vim, is I sometimes think I've copied something, and Vim says that I have not copied it, and I don't understand why. Go figure. All right. So better put those in comments, and here we go. Russell says, I just found out that Rust is the most loved programming language. Yeah, I've seen various things to that effect, although I'm not sure what the source is. I can certainly believe. I personally love Rust. I'm always a little bit suspicious of claims like that because I think it's kind of source dependent. But I mean, it's really a pleasure to work with. Even if I'm writing like a quick script, I'm pretty close to indifferent between writing it in Python and writing it in Rust, even though Python is clearly the scripting language of choice, which I think says a lot for Rust, and certainly for anything that I want to put in production. I would far prefer to be working in Rust than any other language, unless I have some reason for it. Okay, let's think about this. So, AY. So this is rock versus rock, paper, scissors. Rock versus paper. Maybe I'll just do all of these first. Paper versus scissors. Scissors versus paper. Paper versus paper. And rock versus paper. So this is going to be so rock loses to paper, so 0 plus 1 is 1. This is going to be paper loses to scissors, 0 plus 2 is 2. Scissors beats paper, so 6 plus 3 is 9. Paper is a draw, so 3 for the draw, which is a stupid rule, but what are you going to do? Is 5. And then rock loses to paper, and is another 1. So this is, if I did this right, 11, 12, 13, 18. Hey, that's the same number we got here. Good stuff. Okay. Test that. And now our helpful error message should give us the answer. 9226. Stack Overflow survey. Yeah, well, that's a pretty good source, I think. Yeah, I would think, if anything, Stack Overflow. I don't know. Do I think it'd be biased in one direction or another? It's probably a little biased towards new languages, right? If you work in JS every day or Java every day and you're a little bit frustrated by it, and you go home at night and you do your hobby programming in Rust or Go or something, you're probably kind of excited to say Rust or Go, and you probably are less likely to say Java or JavaScript, but I'll take it. I certainly hope that Rust continues to get acknowledgement like this. Let's throw an answer in here. 9226. Uh-oh. Not the right answer. My answer is too low. Okay. I'm pretty sure I just didn't read the rules right then. Probably. Let's see. Because I feel like I'm definitely doing the thing that I set out to do. Seems unlikely that this test could pass otherwise. Let's just check and make sure the whole input is in the file. 2,500 rows sounds like a nice round number. Okay. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected. 1 for rock, 2 for papers, 3 for scissors, plus the outcome of the round. 0 if you lost, 3 if it was a draw, 6 if you won. Seems suspiciously like what I've implemented. the total score if everything goes exactly according to your plan. Alright, let's just, for sanity's sake, let's throw their puzzle input in here and make sure that we agree on that. Problem 2. Let's say, let example input, and this can just be a vector of strings that are going to look more or less like this. Definitely a more efficient way to do that in Vim. Right, and then this was AYBXCZ. So I did this wrong. ToString and y.ToString. Okay, that was the more efficient way to do it. BX and CZ. Okay. And so then assert equals example input, let's say solve, what is it? Solve problem O2A on example input, and we expect to get back 15. And we do. We do. Our test is getting all the way to here. Interesting. 9226. Is that what I entered before? What would your score be if everything goes exactly to plan? Encrypted strategy guide. So I'm able to match their example. Am I somehow not picking up the first or the last puzzle input? Or something? Assert input.length is, what did I say it was, 2500? Yeah. Okay, we're getting the whole thing. 9226. 9226. Yeah, it's too low. 9226. The answer is too low. But it works on this. And it works on this. 2500. Let's just double check that this is indeed 2500. Yeah. Seems to be 2500. I'm confused. Okay, my next suspicion is that somehow my test cases aren't representative. So rock loses to scissors, yes. Rock loses to paper. Yes. Rock beats scissors. Yes. Paper beats rock, yes. Paper loses to scissors, yes. Scissors lose to rock. Scissors beat paper. And otherwise it's a draw. That all seems pretty good. In the first round, your opponent will choose... Oh, bingo. Okay, that's the issue. My opponent chooses rock. I should choose paper. That means that my number is the second number, not the first number. And it's just that both examples I chose, or this example I chose, is symmetric, I guess. Okay. That's weird. That's weird. I don't like that order. It's not my intuition. I would always put my own thing first. Maybe that makes me egotistical. Okay. Where to reverse the order? We can reverse the order in the evaluate function. We can just name it well. Why don't we just reverse it when we parse it? I think that's fine. Let's just make this x2 and this x0. And then we'll do the same thing here. x2, x0. Okay. And now my tests are going to fail, which is fine. We know they will. Can compute round score, still passes, which is wrong, because now, oh no, this is right, and then we reordered it, and so we expect a failure here. Okay, so we expect a failure here. We expect this to get reversed to... don't want to do that. To be y. Again, I'm sure there's a nice way to do this. So this is a z. And this is B, C, and B. Okay. And so now all of these change also. All right, so let's just redo these. Let's see here. Let's do it like this. So this is usually paper, and this is usually, we'll say also paper, in which case these are always 3 plus 2 is 5, but then some of them are not paper. This one is rock. one is scissors. This one is scissors. This one is rock. So this becomes 6 plus 2 is 8. Same thing here. This becomes scissors beats paper, so 6 plus 3 is 9. This becomes, these are all going to be plus 2, and then this loses, so 0. This ties, so 3. And this one we already did. So this should be a 2. And the rest of these are good. I don't think I did this in the most error-proof way possible, but I think I did it right. Yeah, that looks right. So that's 18, 20, 25, 33. Ooh, 32. 6 and 2. 6 and 3. Paper versus scissors, you lose. 0 and 2. You draw. 3 and 2. You win. 6 and 2 is always 8, never 9. And that equals 32. Okay. 32. And okay, and we get a bigger number, which is what we would expect. And boom. Okay, cool. That solves the first half of the problem. Let's look at the second one. Cool. Part 2. The elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. This is annoying. Okay. The total score is still calculated the same way, but now you need to figure out what shape to choose so that the round ends as indicated. The example above now goes like this. In the first round, your opponent will check. Okay, yeah. Now that you're correctly decrypting the ultra top secret strategy guide, you would get a total score of 12. Following the elf's instructions for the second column, what would your total score be if everything goes exactly according to your strategy guide? Okay. Lost Soul says A.2string, isn't that already a string? Yeah, so in Rust there are multiple different types of strings, and this is true in C also. And it's always a little bit tricky to explain. The type of this is a reference to the type called str in Rust, which I don't know if I have any examples of here. It's not. I believe it's a heap allocated. No, sorry, a stack allocated string. If it's a str, which is just what is the type of the thing. If you just say let hello equal hello world, then this is an @str, which I think is stack allocated. It's different than, it's a much more stripped down version of a string. The internal representation of it, you can do a lot less with it than the actual string type, capital S string. which is heap allocated, and is like a vector of characters, basically. So it tends to be like STR is the more low level thing. It's probably faster. It's probably, I don't know, there are probably a bunch of good things about it. I'm sure the rabbit hole goes really, really deep on what you can do with at STRs, whereas strings are a little bit more like a vector, and they have functions available on them, like, strip and join and things like that. It's a little bit more high level, but it's going to be like slower and less efficient. So if I didn't put a toString in here, I will get yelled at, because now this example input wants to be a vector of @string string, and these other elements of the vector will be the wrong type. Hopefully that clarifies. Okay, cool. So now there's a funny thing here where some of my types are a little bit weird. I guess it's fine though. So I'm gonna rename this guy and say from string problem O2A, just because it's not quite right for O2B. And then we'll say pub function from string self. And now we just have match S as str. And we can just take this stuff. And we don't need this. Okay. And then it seems like we're going to need a new... it's not a string object. Yeah, exactly. That's a nice way to think about it. It's like a pointer to a raw string. Okay, so now we just need a way to infer what the move is that we should play. So first of all, our outcomes now get a from string method. And we will say this is a string and returns a self, and we match. And these matches are one of my favorite things about Rust. It's just really nice to be able to do this pattern matching. So let's see here. X means you need to lose, Y means you need to win, Y means you need to draw, Z means you need to win. So X means you need to lose, Y means you need to draw, Z means you need to win. Okay. And this has to be, oh right, and then, yeah, so Rust is helping me catch an error here, which is that this pattern matching wasn't exhaustive before. So now I can say, if you give me anything else, I'm going to panic, I'm going to crash the program, and say invalid outcome. And there are other ways to handle this than panicking, but I am fine just panicking here. Okay, and so now it would also be nice to have the necessary outcome give a function for telling me what I need to play. So let's say and shape, we'll say hand shape to achieve, let's see, get hand shape to achieve, that'll take a self and a opponent shape, which can be a hand shape, and it'll return a hand shape, and it'll say match self opponent shape. Let's see here, we'll say if self equals draw, then return opponent shape dot clone. Those are redundant. This is going to be like, this needs to be a reference, maybe? Or does it just not know what equal is? Equal can't be applied to, okay, it just doesn't know what equals means yet. Let's derive a bunch of stuff. This is another really nice thing in Rust, that you can take a type, like an outcome, in this case is a type I've defined. It's an enum, but it could also be a structure. It could also be basically a class. And you can derive a bunch of traits on it, which is basically just a bunch of properties. And in a lot of cases, it can work out how to derive those properties. So in this case, in particular, it's able to derive how it should do equality. So that now I can do things like compare two outcomes to one another, and the way it derives it is it just does it based on each possibility that the enum could take. But it's a really, really slick way to get really expressive types, I think. Cool. So if this is let's actually do this the other way. It just makes more sense in my head. Match opponent shape self, and we'll say hand shape rock self win. Yeah. Bit better. Really gotta learn how to do some of this stuff better in Vim. Okay. There are going to be 6 of these, not 5 of them. So, rock can be a win or it can be a lose. These are both paper. This can be a lose. And then these are both scissors. Okay. And if it's a rock and you need to win, then you need to play a paper. If it's a rock and you need to lose, then you need to play scissors. Got a bunch of extra white space there. If it's a paper and you need to win, then you need to play scissors. If it's paper and you need to lose, then you need to play rock. If it's scissors and you need to win, then you play rock. And if it's scissors and you need to lose, then you play paper. Yeah, so paper beats rock, scissors loses to rock, scissors beats paper, rock loses to paper, rock beats scissors, paper loses to scissors. That seems right. And some of these need to be references. Non-exhaustive pattern, sure. And then all of the other of these we can panic, because actually we can do one better than that. We can say anything. We can say this and self draw. And then we needed to draw, but didn't return above. Like, this is unreachable code. Nice. And I think it's kind of slick that Rust understands that we've exhausted one of the tuples. So we didn't need like an underscore comma underscore case here, which is slick. Okay, so that gets us the hand shape to achieve a certain outcome. Is it worth doing a test of this function? I don't really think so. So now we just say, we take input, we throw it in an iter, we're going to score the round, same thing as last time, but this time it's between, let's add some better white space in here. But this time it is the left-hand side, and then on the right-hand side it's going to be what? It's going to be we're going to need to get outcome from string from the right-hand side. We're going to put that into let's see here, that's the outcome. What was the name of that function I just wrote? Get hand shape to achieve. Get hand shape to achieve. That's with the left-hand side. And then we can turn that into a reference. And return. Left-hand side. And what have I done? Oh, I didn't close my lambda. Okay, and then I need to sum up the results. Yeah, so that's going to take our input, which is a tuple of strings. It's going to stick it in an iterator. It's going to map over that tuple of strings. It's going to score each round where the left-hand side is the left-hand value that was passed in. This is gonna throw. This is backwards from what it needs to be. It needs to be outcome from string, left-hand side, and then we need to achieve it via the right-hand side. And then this is right-hand side. Yes. All right. Let's look at the question. So the question, X, Y, and Z. And then the puzzle input those are on the right-hand side, so they're going to be on the left-hand side when we run this. So we're going to get the output first, and then we're going to make sure that we can achieve the left-hand side, or the right-hand side. Get hand shape to achieve. I can't spell. And we're missing a comma. I don't need that comma. And this should be a reference. Oh, this needs to be hand shape from string. There we go. And this needs to be a reference. Nope. This does not need to be a reference. We need to clone this one, because otherwise we're trying to borrow it twice. Yeah, and so this is the other pretty major feature of Rust. This is like probably the thing that distinguishes it. Is in C, I would have been allowed to do this, where I'm passing in this right-hand side string to two different functions, and there's no guarantee that each of those functions doesn't mutate that value, leading to confusing behavior. But with Rust, it has this feature called the borrow checker. People complain about it, but they shouldn't, because it's making you, it's basically encouraging you to write good, safe code, where it's saying, like, look, you already tried to use this, you already tried to move this value, this variable, into another function, and I don't know what you did with it there, and so I'm not going to let you continue to try to use it again until you clear that up for me. And in this case, the way I can clear that up is by just cloning that value and passing in two different versions of it. Okay. So, last but not least, against the shortened input, what do I now expect to happen? Well, let's see. So this says draw against paper. This says win. It says win versus paper. Oh, sorry, this said draw against rock. Win versus paper. Draw versus scissors. Draw versus paper. And draw versus rock, which is 3, 6, 3, 3, and 3. And then you play not a rock. Oh yeah, you play a rock here. You have to win versus paper, so you have to play scissors, so you get the full points there. You have to draw versus scissors, so you play scissors. You have to draw versus paper, so you play paper. And you have to draw versus rock, so you play rock. So this is 4, this is 9, this is 6, this is 5, and this is 4 again, which is 13, 19, and 9 is 28. If I'm doing my math correctly, which is always an open question. My terminal is frozen for reasons that I don't understand. I will exit my terminal. There we go. And oh, problem 2a isn't passing because I never put the right answer in here. Okay, 2 of them are passing. And then instead of getting, okay, and then we get 28 here, which is what we expected. And 14, 416. And so this is a higher result than, oh no, it's a lower result than before. I don't know that I have an opinion about that, but it's in the same order of magnitude, so that feels pretty good. Lost Soul says, meanwhile, JS security, null greater than equals 0 is true. Yeah, those are the sorts of things that Rust is really good at avoiding. So Rust also does not have a null type at all. It has no such thing. It uses the idea of an option instead, or a null value, I should say. It uses the idea of an option type instead, or a result type, and the compiler forces you to handle that null type. It's just really, really nice. It's funny, I was just talking to a friend of mine, and he's, he was running a model. He doesn't work in software or anything, but he was running a model that's written in Python. He knows a little bit of Python, and he's like, the model's erroring out, and it's throwing a Python error, and it's just like a null pointer exception, basically. And, you know, he's not thinking in terms of, he doesn't want to be thinking in terms of Python errors. He wants to be thinking in terms of what the model does. And it's just so easy in Python to not have good error messages, whereas Rust essentially would force you to. Cool. Okay, I think this is the right answer, probably. I've said that before, but we'll see. Let's try it. Boom! Okay, got that one in one. That's good. Alright, that was day 2. I have like half an hour more. Yeah, let's keep going. Let's just keep going. Rucksack reorganization. One elf has the important job of loading all of the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packaging instructions, and so a few items now need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. Okay. The elves have made a list of all of the items currently in each rucksack, your puzzle input, but they need your help finding the errors. Every time a type is identified by a single lowercase or every item type is identified by a single lower or uppercase letter. That is, A and A, lowercase and uppercase, refer to different types of items. The list of items for each rucksack is given as characters, all on a single line. A given rucksack always has the same number of items in each of its 2 compartments, so the first half of the characters represents the ones in the first compartment, second half is second compartment. For example, and we have an example, and it makes sense. Okay, I didn't understand that actually. So capital A and lowercase a are the same type. Okay, different types of items. Sure. First compartment is all of those. Second compartment is all of these. The only item that appears in both compartments is lowercase p. Second item. Second rucksack's compartments contain those. Only item that appears in both is uppercase L. Okay. Third is uppercase P. Fourth V. Sixth T. So on. To help prioritize item rearrangement, every item type can be converted to a priority. Lowercase items have priorities 1 through 26. Uppercase have priorities 27 through 52. In the above example, the priorities that appears in both are those. Figure out the sum of the priorities. Okay. This doesn't seem bad at all. Let's grab the puzzle input. New file. Input 03. And there we go. Okay, so parsing is not going to be much of a problem on this one. So we basically need to identify the shared item and then map it to its priority and sum them all up. So finding the shared item is going to be the fun part. The easiest way to do that is probably to throw them into hash sets. And then intersect the hash sets. So that should be pretty straightforward because hash sets know how to intersect. And then we just need to map them to their priority, which is a slightly annoying like language level thing. Do characters have numbers in Rust? Rust char to number. Not that. From digit. I want the size of it. Characters are valid U32s. I wonder if the characters are in order. Let's check. Test. Char to U32. Assert. Lowercase a as U32 is something. And then, oh, it doesn't even like this. This needs to be a character. Okay. And then we'll do the same thing for B. And let's do the same thing for C. And then we'll do the same thing for A, capital A, B, and C as well. ABC and A, B, C. Okay, and obviously these are going to fail. But what I'm kind of hoping for is that this one is 97, this one is 98, this one is 99. And then this one is 97 plus 26, but we'll find out about that in a moment. Oh. Wait, what did I just do? Cargo test problem of 3 is what I meant to do. Ah, okay, that worked. Cool. So this is 65, 66 and 67 presumably. And let's just throw in one more test to test on Z. So 97 plus 25 is 123, 122, 122. And we'll do the same thing here. We expect that capital Z is 92. Yeah. I missed a semicolon. Sorry. Yes, 90 is correct. I added it to C instead of adding it to A. Cool. All right, so we should be able to use this to write a function that turns these into priority values pretty nicely. So let's write a test for that. Test priority letters to priority. And so we can say, let's just say get priority. I don't think we need a struct or anything here. So the priority for A should be 1. The priority for B should be 2. Priority for Z should be 26. Priority for capital A should be 27. And priority for capital Z should be 52. I'm doing my math right. Hey, Emil Gardis, you have a suggestion for character mapping regarding the question of do characters have numbers? Oh, yeah. Cheers. Sorry, I should have asked you. You knew the answer. I did not, but this is the sort of thing I kind of like to do. It's one of the reasons to do these sort of coding puzzle challenges also, as it teaches you things like this. Nice to be able to go back to it later as well. Okay, so those should be the priorities unless I messed this up or unless I didn't read the question right, which is always possible. Lowercase items have priorities 1 through 26. Uppercase items have priorities 27 through 52. Looks like what I did here. Sweet. Okay, so we'll implement get priority. I guess let's do that first. Get priority, we will take this as a character. We will return a U32. We will what to say, if it's lowercase, then we'll subtract 96 off, and if it's uppercase, we'll subtract 64 off. Const amounts to subtract from lowercase will be 90, what did I just say? 96. This needs to be a U32. And amount to subtract from uppercase is going to be 64. Maybe I'll just throw in a couple test cases there. Let's throw them in here. this will be A as U32 minus amount to subtract from lowercase is 1. And same thing here. Just do Z as U32 amount to subtract from uppercase is 52. And then this will be if C is lowercase, C as U32 minus amount to subtract from lowercase. Otherwise, and there's a case here, right, where C isn't lowercase or uppercase, which I assume should never happen, but I should test for it anyway. C dot is uppercase. Amount to subtract from uppercase. And whoops. Otherwise, we panic. Input was neither lower nor uppercase. Okay. Cool. And now this is just basically functional, right? We don't even need to implement any structs or anything. Uncle Scientist says you could subtract BA plus 1, etc. Oh, Oh, I like that. Yeah, I see the idea. That's nice. Yeah, I guess for readability, I'd probably still throw it in a variable, but then I don't need to prove like these numbers aren't magical. I'm with you. I like that. I'm, however, not going to do it since I already wrote the other thing, and it also works. And I have 15 minutes left. Okay, let's see here. So we can just do this functionally now. Input into iter. And what, these are already going to be vectors of strings, so we can just get for each one there's a rucksack rucksack.chars. I forget if I need to pull that into a, no, I think that's right, it's just an iterator of characters. And then oh, I still need to pull this into a hash set though. So collect this into hash sets. I also still need to split this in half. Okay, maybe I don't just want to do this functionally. Maybe I don't just want to do this functionally now that I'm thinking about it. Also, why is this public? Let's do a function. Get common element. Rucksack is a string. We want to return a character. And we will say let first half be rucksack chars and just take half of them, I guess. So we can do let length is rucksack length. We can make sure that length mod 2 is 0. And then we can let half length be length divided by 2. Take half length. Collect it into a hash set. And do the second thing. Second half is rucksack cares. Actually, I guess we can pull this out. Rucksack cares. Take half of it, take the other half of it, which really should be all of it, and we know is all of it. There's probably an error checking thing here, but I think it's fine. And then we'll compare them. Import that. Get the intersection. This is the first half. Intersection, the second half. And panic if it's not 1. Otherwise, return it. Okay. We can do that. Okay, cool. Emil says iterators need to be mute. Yeah, that's probably right. Surprised I'm not getting yelled at by the compiler yet, but it's probably because this guy is erroring. Cool. So now let's just put that into get common element. Don't need to collect anything anymore. So now we have the common element. We can just put it through get priority and sum everything up. Needs to return a U32 now. This one also will need to return a U32. And maybe we're happy. Maybe we're happy. Let's see. So we take our input. Our input is rows of characters as a string. We get the common element in the 2 halves of the rucksack. We get the priority. We sum everything up. that what the question wants? Priority of the item that appears in both compartments of the rucksack is, and then each of those. And sum it up. Cool. Seems reasonable. This all looks like it works. Interestingly, does not think this iterator needed to be mute. But it is offended that I moved it. Interesting. So the problem here is that we're taking values out of the rucksack cares iterator and collecting them into a different thing, and then we're trying to take more values out of it, which it does not like. I mean, there's probably a more efficient way to do this, but I can just clone it. It's not going to be super slow. It's fine. Okay. And then let's check. So taking the first 10 for a test case seems like more than I want to take. Let's do 3 of them, honestly. 3 should be plenty. And so what do we think? Those are... Oh, wow. Why is this formatted like this? Oh, is this right? Oh, yeah. Okay. Each row, the rows can be different lengths. The rows can be different lengths, but there's only one ambiguous element in here, which is fine, and I didn't create an annoying bug where I turned it into a hash set first, did I? Half length cares. No, I didn't. Okay. Cool. Scanning for a repeat element. My brain cannot do. Easily. My brain really cannot do that easily. In the shorter case, is it T? It's okay. It's T on this one, right? Because it's this half and that half. So here it's, let's copy these out. And so this one is lowercase t, which is going to be something that I'll figure out. This one is uppercase H, which will be something that I'll figure out. And this one, I could not find myself. Lowercase q, somebody says. I don't think so. I think that's... Oh, maybe. 22 selected, and 22 selected. Yes, it is lowercase q. Nice find, Emil. Okay, lowercase q. And what are those? H is the 8th letter of the alphabet, so this is 26 plus 8 is 34. Q is the 13, 14, 15, 16, 17th letter of the alphabet, I think. 17. I'm just going to throw these in test cases. And T is 3 more than that, so it's the 20th letter. So we expect this to be 17 plus 34 plus 20, which is 54, 61, 71. 37 and 34 is 71, yep. Okay, let's just find out if I did these right first. Get priority of Q is 17, I think. Get priority of capital H is 34. And what was it? T is 20, I think. Dollars to donuts. I got at least one of these wrong. Yup. Shocking. Oh, hang on. That was not my problem. That was not my problem. Did I do this wrong? A is 65. 65, I need to get to 27. I did do this wrong. That's, what, 38? So, that was the wrong test. Okay, that's passing. NX Thor says, why not test on the example input? There are all results given. Yeah, I do that also. At least some of the time. In this case, it is probably easier too. It's a good point. I kind of have I like generated all of the boilerplate for this, and so for a lot of them, it's been easier to just validate the input myself. But for this one, it's kind of a pain to do it manually. I don't disagree with you. Let's actually do that. Let's say example. And what is their example? These. Oops. So these need to be what? These need to be strings. What did I say? Solve problem 03A on example. And the answer to that should be 157. Okay. Okay, so one of our other tests is failing because this is not ending up being unique. Interesting. Is this meant to be... Yeah, there are 6 items in the list. So the length was even. We got what half the length is. We took the characters. Oh. This doesn't work. When I clone here and then I take, it doesn't remove the characters from the previous one. So I have to say .skip half length here and then take. That's the issue. And now, okay, so now, so the example passed, so the example was correct. This is saying 93, not 71. That's because I never updated something. This passes. This definitely adds to 71. I assume I just made some mistake in my calculation. $22, that one's okay. This one we said it was H. 10 versus 10. Looks like it's H. And this one is 9 and 9. Looks like it's T. Like, highly suspecting that I did something wrong in the example rather than in the solution, given that this passes. Yeah, exactly, Emil. It's not even 71. It's just, that was just the boilerplate that I had in to begin with. Yeah, 93 is not 71. So we're off by 22 for some reason. 22 seems like an odd number to be off by. And it's not, I'm making sure I'm not misunderstanding the question. It is the case that I'm not looking for like an uppercase P and a lowercase p on each side. I'm looking for lowercase p on both sides, yes. And in fact, my test already passed so on the example, so I kind of know that I'm interpreting it right. My input right? Should be. But let's check. Shortened input. 0 should be this. Oops. Is that not pasting? Sorry, I'm learning Vim and I'm not so good at copying things yet. Is the bar tracker going to yell at me a lot? Yeah, the bar tracker is going to yell at me a lot. Let's just do it in the debugger. And if it's not obvious, just going to, whoa. Debugger is not happy with me. It's trying to put me into all of the language functions. Nice. Let's jump here instead. It should be a little more like it. Shortened input. RN, blah, 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 all the way to J. P all the way to G and all the way to Z. Yeah, those are correct. Those are correct. Interesting. Alright, let's just try and slam the answer in. Emil says shorted versus shortened. There is a typo. You're right about that. But I don't think it's causing any issues. It's a typo in both places. I'm going to just try and put in the answer because I need to go in a few minutes. And I think there's at least a 50% chance that it's just an issue with my test, not an issue with the output. So the output we're getting is 7691. Let's give it a shot. 7691. Okay, it's correct. Yeah, I don't know what I did with the test input, but that's fine. Cool, that is correct. I need to wrap up in a couple minutes, so I think I will probably start next time, which will be tomorrow at 1 p.m. EST. I'll start next time with part 2 of this question, which I will read then. Thanks everybody for stopping by. Emil Gertis says to compile that as clap. Cheers. Next Thor gives me a robot smile. Uncle Scientist claps. Thanks, guys. I appreciate it. Appreciate the help trying to debug. Maybe I'll take a look at and try to figure out what I actually did wrong here. But we got the answer. So if you guys want to follow, come back tomorrow. I'd appreciate it. And these are also on YouTube, as well as some other content if you're interested. But everybody have a good day, and hopefully I'll see you tomorrow. Take care.